Hello folks, and welcome to another Leetcode question. We're given an n times n matrix with characters and a string word. We need to return true if the word exists in the grid. So by definition, we need to go through the board sequentially until we link all the characters and image the word. Same thing here. If I go starting from S and links all the nodes, you can match. Next, I'm going to talk about the DFS back-tracking approach. Let's denote the DFS as the recursive function. Inside the function, we have this is I and this is j. I, that means the index for the row, and then j, that means the index for the column. The third parameter, I'm just going to call it index. And this is the index for the word. In the matrix, we are starting from here. We know that the character of the matrix is matching the word at the first index. And let's go to the next recursion. Notice that from here, I can go into 4 directions: up, right, down, and left. But since the left and up, they're outside of the boundary, so I will eliminate them. So the first recursion, that means moving to the right, because the j index plus 1. And the second recursion, that means going down, because the I index plus 1. And we also need to move from the index for the word, because we already passed the first one, so it's moving to the second character, which is B. We know that if we are going down, the character from the matrix is S, so it doesn't match the B. Therefore, we won't go to this recursion. So the path from the recursion is going like this. First, I'm going to go to the right, and then go to the right. So I'm from here and then here. The next thing, I need to go down. So we're following this path. And the other path, we choose not to go. This is because at index 1 and 1, this is character F, and it doesn't match. At index 0 and 3, this is character E. It doesn't match at all. So what is the base case for this recursion? Well, if the recursion DFS goes down, and we're moving the index from left to right until it reaches to the last element, that is, the index is equal to the length of the word minus 1, then we need to return true. Notice that we cannot always start at index 0 and 0. If the word is equal to DECCBA, that means the starting point is actually here, and it goes to the DFS. So the solution of this question is by performing the DFS on each node, following the whole matrix, until we find a match. And there's one use case that you need to be careful. Let's say we have a D in D. So if you're starting at D, you can go to E. Because the third character is also D. So by previous DFS, you can actually go back, and this is not what we want. This will form a loop. And going back to the previous recursion tree, if we are going to the right here, on this node, we can perform 4 actions. Go to the up, right, down, and left, right? And we need to prevent it going back. So we need to mark the previous node to be visited. In this case, I'm just going to use the number sign as it's being visited. And if I keep the number sign all the time, this is not good enough. Think about the use case that if there exists the path going like this, and then eventually it reaches to the number sign here, and this is considered a valid path. If you don't get rid of the number sign here, then this path will not happen. And that's the reason we have backtracking here. This is the Python code. First, I assign the original value into the temporary variable. I mark the node as visited, and this is the recursion. After we are returning from the recursion, for example here, I need to recover this as visited back to the original character, which is C. And that's the reason I have this code here. So as we are hitting to the base case, while we are returning, we recover the node to be D, and we recover this to be E as we are return to the root. And one thing I need to say is that I have this global variable here. If I reach to the base case, instead of return the recursion function as true, I assign this global variable to be true, just for simplicity. So in the end, we can just return this variable. And the time complexity of this question is m times n times w. W means the length of the word, m means the number of the columns we have, and n means the number of the rows we have. Because in the worst case, the height of the tree is w, and for each node, we need to perform the DFS.